Hello, those of you who are joining us online. Here comes your warm-up. Yeah, go ahead. Anytime. That's totally fine. Oh, yeah, it's totally fine. You never have to ask. As long as there's no one up there, you're good. That's generally the rule. Okay. Okay. Copy that, and here we go. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1? Lydia, let's see here. Number one, are you secretly hoping that I don't get that seating chart done so that you can kick me in the shins? Okay, that's good. She has a big smile on her face when she says no, though, so part of me is wondering. Anyway, here we go, guys. Max is like, I got this. Don't worry, Lydia. All right. But Lydia, let's get to this. If we're going to use the distributive property to multiply this through, what am I going to do with that 6? How am I going to work this? Yeah, you multiply the 6 by each of these numbers. Now, 6 times 3 is 18. That becomes 18a. 6 times a negative 4 is a negative 24. That becomes a minus 24b. And 6 times 2 is 12, a plus a 12. Is that what you got here, Lydia? How many of us got 18a minus 24b plus 12 for that, or see how we got that? Great, excellent. Well on our way. Well on our way. Good. Now, number 2, let's see if I can get a little bit of help from Matthew. Matthew, what am I going to do to simplify this? Or expand this? What should I do with this negative 5? You buy what? Oh, multiply what by 5? I'm glad we're talking. And in fact, can someone actually use one word to say what he needs to multiply by 5? One word, Finley. What does he need to multiply by 5? Sure. So that's a start. And remember, this is a negative 5. And negative 5 times 3 is a negative 15x. Can someone tell me, someone could have said the entire thing. I wonder, what one word, what do we multiply by negative 5 in those parentheses? In one word. Charlotte, what do you think? Uh-huh. You know what I would say? Everything. Everything. If you multiply everything inside the parentheses by what's on the outside, you guys are going to get what you want. Now, this is the part that really freaks people out. This times this becomes a minus 10y. This times this becomes a plus 5y. Sorry, 5z. And this times this becomes a plus 35. I'll tell you right now, most people feel just fine and dandy about this negative sign, but start to get really nervous about this minus, this plus, and this plus. If someone didn't understand where the minus, the plus, and the plus came from, because those were different up here, what would you tell them? Teach, teach!
Okay. Wait, Mr. Petersen.
Yes.
Why would you? So I got plus negative 30.
Yeah, and that's mathematically correct, but to simplify it, adding a negative is just subtraction.
Oh.
So we just turn that into a minus sign. I love that. There you go.
So what happens if I accidentally do that?
That'll be an easy fix. It'll be an easy fix. In fact, we'll talk about that. Let's do that right now. Oh, Alex. What can I do for you, sir?
I can't really see.
Ah, okay. Let's see here. I wonder. We'll. You know what we might do? I wonder. Do I have enough spots? I think what we're going to have you do is if we can have you over here at table D today, if you're having trouble seeing, okay? Table D, we'll try that. Okay? That's me.
I think you forgot to say what's going on today.
I haven't got there yet. I haven't got there yet. We do the warm up, and then we do the stuff, and then we do the essential questions, and then we do Jeopardy and Pictionary. That's how we do it. We got an order to things, man. All right. Can I get you in 5, 4, 3, 2, 1? Shh. Oh, that was a great countdown and a great Teach OK session. I think you guys do deserve a point for that one. Well done. Now, Avi, where did these signs come from? Why is that a minus 10y? Why is it a plus 5z? Why is it a plus 35? Excellent. A positive 2 times a negative 5 makes a negative 10. Excellent. A negative 1 and a negative 5 make a positive 5, and a negative 5 and a negative 7 make a positive 35. That's exactly right. Max actually asked a really good question, which is, here's what he wrote. He wrote negative 15x plus a negative 10y minus a negative 5z minus a negative 35. Now, guys, that is mathematically correct, but it's not what we would call simplified, because adding a negative is the same thing as subtraction. Subtracting a negative is the same thing as addition. That's why we need to make sure that if we see something like this, it's kind of like multiplication. A positive times a negative should turn into a minus. Negative times a negative should turn into a plus. Negative times a negative should turn into a plus. That's how I would think about it. Perfect. You got that all filled in? Yeah, fill it in for me. Fill it in for me. Okay. Now let's use the distributive property in reverse to factor this expression. Let's see if I can get a little bit of help. Olivia, how many care packages could we split this up into? 5, because all those numbers go into 5, or 5 goes into all those numbers. So I'm going to have 5 on the outside, and then a bunch of stuff in the parentheses. So 5 times what would give me my 5q, Olivia? 1q. And then 5 times what would give me my 10r? And then 5 times what would give me that 20? 4. Now we have to make sure we put the signs in, right? So Olivia, what sign belongs between the q and the r? A plus or a minus? A plus. And what belongs between the 2r and the 4? A minus. Yeah, we just got to make sure those match, and we'll be in really good shape. That's awesome. Yes, go ahead. Max, go ahead. So when you use the distributive property forwards, like we did when we expanded them, you multiply. But when you work backwards, you divide, which makes sense because we're going opposites. Now, there's one thing we have to do in order to make it so that this is an acceptable answer. Ellie, you think you know what it is?
Yeah.
What is it?
So I think that you don't have to write 1.
Right. We're going to erase the 1. And the reason is because it's just like I was talking to Casey the other day. Almost never do you look at somebody and say, hey, I like your 1 hat. Right? Hey, you have 2 shoes. Right? Like, I like your 2 shoes. Like, we tend to like when we're talking about like a single object, like we generally leave that 1 out of there. So we're in good shape just like that. Great. Very good. Okay, let's see if I can get a little help on this next part. Let's get that from Josie. What number could I pull out of number 4 here? 8? I'm not sure, because I don't think that'll go into 12 or 20. There's more than one answer. What do you think, What do you think, Josie? What do you think? 4, absolutely. You could pull a 4 out. And so, Josie, what times 4 would give me my negative 12t?
3.
3t? And then how about, what would give me my negative 8u?
2.
2u. How about my plus 16?
4.
4v. And then my plus 20?
5.
5. What about signage here? How am I going to fill these in with plus or minuses? Let's see here. What's going to go right here?
Negative.
A negative, because it was a negative 12. And how about right here?
Plus.
Okay, how about right here?
Plus.
Okay, and how about right here? I would say one of these signs is incorrect. It's okay, that's good. That's good. It's good to talk about. When I say teach, I want you to say, okay, which of these signs is incorrect and why? Teach! All right, can I get you in 5, 4, 3, 2, 1? Luke S., What do you think? Which sign of these is incorrect?
I think it's the plus sign in between the 3t and the 2u.
I agree. Why does that need to be a minus?
Because it was -8.
Excellent. And 4 times -2 would give me a -8. One last thing I want to say about this before we move on to the next thing. I have seen people who have factored out negatives before. And technically, if there's a negative in front, it's more factored if you have it this way. I'm not going to make you do it. This is a perfectly acceptable answer on Canvas. But if someone did factor out a -4, what would happen to the inside? Talk to each other and teach. Yeah. What's that? Because 4 goes into all of these numbers. That's how you know. And the thing is, you could have factored out a 2, but then you could have factored out a bigger number. And to be fully factored, you want the biggest number possible. Okay. Can I get you in 5, 4, 3, 2, 1? By raise of hand, can someone tell me what would happen if we did that? If we did that, what would happen, Nora? Yeah, you would just change the signs. Those are both perfectly legitimate answers on Canvas. Well, I'm just trying to show you that it's all good if that's what you do. There we go. Yes. Aha, all right. So, perfect. Exactly so. Now, come on up in 5, 4, 3, 2, 1. It is the 49th day of school. Did you guys know that the 49 is the lowest number with an unknown home prime? Let me tell you what that means. Let's think about the number 4. Let's find 4's home prime. If we make a factor tree for 4, what numbers multiply up to 4? 2 and 2. Now, guys, normally we would do 2 times 2 is 4, but we're going to pretend there's no multiplication sign. What number would that say if there was no multiply? It would say 22. So the next number is 22. Then we have to ask, is 22 prime? Yes. No. You can factor that into 2 and 11, and you have to go in numerical order. And we forget the multiply, so what does that say? 211. 211 is prime, and so 4's home prime is 211. Now, if you try that with 49, you get 7 and 7. That's 77. Is 77 prime? No. Nope. It's 7 and 11. And then that's it. So we get 711. Is 711 prime? It feels like it, but it actually is 9 times, I think, let's see here. 711 divided by 9. It's 9 times 79. Thankfully, 79 is prime. That's 3 and 3. So you get 3,379. There has been a computer running since 1996 trying to find the home prime of 49, and it is still running. It is still looking. It has not found it. And it's possible, and the thing is that no one has proven that there is a home prime, so it might be that it doesn't have one, but it would make it like one of the only numbers that does this. Yeah, go ahead. If it has exactly 2 factors, 1 in itself. Like 7 is prime because the only numbers that go evenly into 7 are 1 and 7. That's the idea. It's World Jellyfish Day. Yay! Today is a day to pay respects to the animal that is the easiest to turn into a hat. Yeah. You tell me an animal that's easier to turn into a hat than a jellyfish. Go ahead. No, you have to kill it and like peel it like a jellyfish. You could pick it up alive and just go. And now it's a hat. Now it's a hat. Now it's a hat. It might. Good luck balancing that on your head. Anyway, Come on up in 5, 4, 3, 2, 1. Shh. I know we could talk about that all day. Is this about jellyfish?
No, but it is National Sandwich Day.
I did hear about that. Just don't put a jellyfish on a sandwich. That's gross. Now, what is
That was pretty good.
our first essential question? And I would love to get that from. I feel like I bug you all the time for it. Let's see, Finley, what's our first essential question today? Whoa, whoa, hold on. That's 7-8 compacted. Next one over to the left. We'll talk about that too. May we practice factoring and expanding? Shh, 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 factoring, expanding, and or simplifying variable expressions. And yeah, the second one is where the heck are Mr. Petersen's Chromebook loaners? Guys, understand that things happen. I think that part of the reason that my Chromebook loaners have disappeared is because of the weirdly threatening language that the thing uses. So like, I mean, it's all. How many of us have walked out of a classroom with a loaner Chromebook? Like for reals? Oh, I know more than that. I know more than that. It happens all the time in this school, and it's okay. I don't think you guys are trying to steal my Chromebooks. What I think happens is you walk out with them, and then you take them to your next class, or you take them home, and you're like, oh no, I have the wrong Chromebook. And you open it, and it's just like, this Chromebook was reported as stolen. Head back to the, turn yourself in immediately, you criminal. Like, that's super not what I want you guys to think. If you accidentally have one of my Chromebooks, just turn it into the front office and just say, I found this somewhere. They're not going to grill you. It's not like it's going to be like, hey, I found this somewhere. And then you start walking away, and they're like, now hold on there, son. Where did you say you found this? Your room, perhaps? Maybe it's best you had a seat, sir, while we have a conversation. And you're like, uh-oh. Guys, that's not what we're going for. Here's the other thing I would like you to do. If you'll do me a favor, and when you're in a class and need to use listen up. That's me. Sure thing. She's on her way. So, guys, if you use voices off, I'm having to argue with a lot of voices, guys. That doesn't meet my expectations or make me happy today. Okay. If you use a Chromebook loaner in a different class, do me a favor, and will you just look at each one? And if it's not the loaner for that classroom, just tell your teacher. Because I have a sneaking suspicion that my Chromebooks are probably in somebody else's cart. This is my guess. That somebody used a loaner and then forgot and then was embarrassed and then put it in there. Yes, ma'am. Yeah, that's why I have to. Hey, guys. We can talk about that kind of stuff later. If in the meantime, if you see one of my Chromebooks, if I can get it back, that'd be great. Henrik? Yes, I know. Thank you. Go ahead. So, mostly since I don't know because a lot of it, two of them went missing when the subs were here, so I can't say for sure. Anyway, born on a holiday, Aubrey G from 5th period right here shares a Christmas Eve birthday with this BYU graduate and author of the Twilight series. So far, I'm surprised it's been so difficult. It's Stephanie Meyer. Stephanie Meyer is her name. Stephanie Meyer is her name. And then classic Halloween songs, that is Monster Mash is correct. Now, come on up in 5, 4, 3, 2, 1. Shh. Here's what I would like you to do. When I say teach, I want you guys to say okay. And at that point, I want you guys to log onto your Chromebooks